Okay, yeah, it seems like recording. Okay, so let me double check. Yeah, it is recording. So in last lecture, lecture number 10, I guess, yeah, we were talking about these 3D modeling commands. We discussed about the extrude, sweep, and revolve. Um, so these commands are very important. And today I will introduce you to the lock command. So yeah, if you compare these three commands, extrude, sweep, and revolve, um, so they have one common property. So that is the cross section is uh, constant. So it is the same cross section. But when you go and observe the real world object, so there are situations where the cross section is not uniform. Or you have um, like the cross section changes as you proceed in the geometry. Say for example, um, this thing. So this is like a bicycle hand grip. Um, so it does not have the same grip everywhere. Like if this view is yeah more, yeah, you can see it here much better. So at the bottom you have a circular cross section. And remember, it does not have to be a circular cross section. And at at the top, I don't know how what this shape is called, but it is a circular and a triangular shape. So if you encounter a problem like this, what you're going to do? And especially if you go to the nature, like organic shapes, like fruits, vegetables, animals, like, um, you will see it. You will see these kind of shapes because they don't have uniform cross sections if you think about an animal. So um, the cross section changes as you yeah, observe it. So okay, in CAD you need to observe these kind of features in the real world. Yeah, real world means around you. So you should observe these differences. Um, so if there is a shape or a part of a shape, part of the body, where the cross section changes, and if you can't model it with extrude, sweep, or the revolve command, then you're gonna have the final. Uh, yeah, then this will be your trump card. Okay, so if nothing else works, then lock will work. Okay, simple as that. All right, let's see how you can use this command in an application. So let's take a look at this geometry. Not this one, actually, this one. That geometry is somewhat the previous one. It's a little bit complex because of this feature. Let's look at this ob- this object. Um, so this is like a figure of ray can. Where if you go to like a supermarket, any place actually, any shop, you will be able to find these kind of products. So yeah, you have this container, and you have Here we have spray gun. No, a spray pump, I think. That's what it called. What it is called. The spray pump. Um, yeah, let's forget about that part and focus on this shape. And if you look at this, actually, if you have an item like that in your house, I recommend you to go and observe that and pause the lecture and go and observe that geometry. So it will make more sense. Um, yes. So obviously, if you look at this, if you look at this object, the cross section changes, like the shape as well as the size of the cross section changes from top to bottom. So here you start with a circular section, and actually we'll not model it here. Um, and here we have like a mother shape, and here you have the grip for the fingers, and here if you come down, the cross section will be more or less elliptical, and at the bottom you have another elliptical shape. So it can be elliptical, or maybe it can be like rectangular, close to rectangular shape. It doesn't matter what is the shape is. So the property is, the important thing that you have to notice is the cross section changes from top to bottom. So if you have something like that, and remember you can't model this one with a revolve command. You will not be able to find a axis or a suitable cross section used for revolve command. See, mm, no, it can't be used. Extrude definitely you can't use. Yeah, so then the loft is what all you have. Yeah, let's see what you should do in this kind of situation. So, yeah, actually, I went through the process so that because I can make mistakes. So therefore, I simply I'll show you the process what you should do. So first, what I did was brought the image into AutoCAD. Then I played with the transparency. So you select the image file. Sorry, you select the image, and here you can actually make it like transparent. So I did that. So okay, look at here. If I want to trace the geometry here, let's say I take the some command, this line, it might it is somewhat difficult to see the path, okay, especially in the very beginning. So therefore, I usually reduce the transparency a bit. Um, yeah, I make it transparent, not reduce the transparency. Uh, yeah. So what I did was I took the spline tool, this one. Okay. So then I traced the shape. So spline is something a curve called as a, a piecewise spline. Okay, so it is like a piecewise smooth polynomial. So if you take the level final year CAD/CAM module, I will teach you this spline tool, the mathematics behind spline tool, and also in some math courses you will learn the spline tool, mathematics behind the spline interpolation. So it is a very useful tool, but I did not cover that in AutoCAD. and I have no intention of covering it today. So, so you guys try it out. So what you do is take this spline command and try to trace the shape of the bottle. Okay. I will tell you one in trick actually. So what I will do now is I will select the spline tool, and from this, do you see this small drop down menu? Small arrow like thing pointing downward. So I will select that of arrow, and from there I'm going to use something called control vertices. So okay, to make it much easier to work with, I will simply decrease the, I'll increase the transparency, I'll decrease the opacity, otherwise you can say, and try to fit the curve to the to the image file. Okay, so this image file can be like coming from an artist. So an artist can draw this shape, and you have to try to match the curve. Okay, so in these kind of applications, you are not like getting 100% accuracy. You can't do it because it's an image file. You will try to match the curve as much as possible. Okay, so that's all we are going to do. Um, so here the you will not be very strict about yeah following these uh, borders exactly, this border exactly. So this would be this would be sufficient enough. So that's one thing. I will first follow this curve, and then I will try to follow this other side. Um, okay, I'll start somewhere here. Try to get the rough shape. Then I will refine it with setup, bring to the front. Okay. Now I will do the similar stuff like in the previous case. Um, so it's all about manipulating this control polygon. So likewise, yeah, that's what I did. Then I went and adjusted the this part. So okay, so that's what you do in these kind of problems. Where is my spline? Okay, don't know why. Okay. Yeah, the curves are there, but it is not showing properly. I, yeah, so I trace the curve. Then what I did was I drew the cross section. So I will explain how that is done because that's so. Let's suppose the cross section is somewhere here. So then I would simply apply a trim. So that would yeah, that would be the bottom section. So now yeah, you need to have like multiple cross sections. So that is the first cross section. So here you place the first cross section, and somewhere here you will, okay, somewhere here you will You will place the second cross section. I'm going to move it a little bit. Um, okay, so I can trim this one. What happened? That- that- Okay, let's see. Trim. Okay, yeah, now it's working. I don't know why that happened last time, but now it is working fine. Okay, for this one, I will draw the cross section here. Right. So the last, I will use three cross sections, one at the bottom, one somewhere here, and one at the top. Okay, if I bring back the figure, yeah, you will see something like this. So then what I would do is draw the cross section. And remember, in AutoCAD, um, you need to be on XY plane to draw some object. Say for example, if you want to draw a circle, an ellipse, polylines, 2D polylines, basically, 2D splines. Yeah, you need to be on XY plane. So, but right now, this is my XY plane. So this is my XY plane. But what I actually need to draw cross section somewhere here. Okay. So that means I need to change my coordinate system to match whatever I want to do. So for that purpose, if you want to if you want to change the coordinate system, for that purpose, there is a command in AutoCAD called UCS, stands for User Coordinate Systems. So you can define custom coordinate systems to match whatever you need. Okay, so this is what I'm going to do. I'm going to take the UCS command. I'm going to place the origin here. So this will be my x-axis, and I will turn on auto F8, and that would be my y-axis. So y-axis will be perpendicular to the current XY plane. So if I enable the grid, yeah, this is your, yeah, this is your grid now. Um, so once you change the coordinate system, then you can use like a ellipse command. So here, and draw an ellipse or whatever the cross section. Okay, start, end. This the axis is something like this. So that would be the first cross section or the bottom cross section. And similarly, I will change the UCS again to this point. So then I will use the ellipse command, uh, ellipse, and draw an ellipse. Okay, I'm not, so this time I'm not worried about the accuracy. I'm just showing you how to do that, how I did it. So in your case, you need to measure the actual value with yeah, somehow, and use those values. So I'm going to use the UCS again, change the coordinate system to this stuff, this edge, and this time I'm going to draw a circle. Okay, circle, put the midpoint, right. Okay, so you see that I have three cross sections, and and I have these two, what you call guides. Okay, so this is what I'm going to do. Interpolate. I'm going to interpolate between these cross sections. So for that one, the command is loft. So LOFT, or otherwise you can go to Home tab and here on the modeling, this is the loft command. So what I'm going to do is I'm going to select these cross sections. Press enter once you select the cross section you need. By the way, I can press I can press the enter again. So if I do that, this is the shape I get. It is like a fancy shampoo bottle. Um, yeah, if this is what you need, you can stop there. But this is not what I'm looking for. So, right. So that is the basic lofting. So here you simply select the cross sections in the correct order. Okay, let me show you what happens if you select it in the wrong order. So I select the bottom cross section first, the top one second, and the third one like that. So now that is the shape I get. So yeah, it is some completely different than the previous output. Okay, so the order matters. You need to pick these cross sections in the correct sequence. Otherwise, you will be ending up with something ridiculous. Uh, Okay, let's go back to the loft command. So I select these cross sections. Also, so the place you click on your cross section is also mattered. In some cases, if I click the bottom half of this ellipse and the top half of that ellipse and bottom half of this one, sometimes, okay, not no, this will not happen for every cross section, but for some cross sections, AutoCAD will find it difficult to figure out how to interpolate between these cross sections. But in this case, since these are very small, very simple geometries, it has no issue. So it will, yeah, it will give you this out. Okay. So make sure that you are consistent with where you click on these cross sections. So if you are if you are clicking on the upper half of the cross section, yeah, try to you stick to the upper half on all the cross sections. So like here. Okay, so these are my cross sections. By the way, if you have like here, I'm only using three cross sections. If you have more than three, completely fine. You can select them in the correct sequence. Okay, remember, correct sequence is a must. Right now, the cross sections are selected. So what you do is you press enter to confirm your selection. Okay, now if you look at the command line, you have additional options. So what I'm going to use is, I'm going to use this option called guide, and I will select these curve. Now you see, okay, let me try to remove that curve. Okay, yeah. Now you see, without the guide, this is the shape. As soon as I select the guide, now you see the, yeah, shape that you might need. Okay, for this, For the second guide, actually you can select more than two guides. Okay, I'm going to use only two guides. For the second guide, I'm going to use this curve and press enter if you are done with the guide selection. So you can use say four or three or any number of guides, but okay. So this is the shape that I get. Kind of neat, right? So the loft is a nice tool to use. Uh, yeah, you will be able to form your shapes to match whatever the guide curves you have. Um, yeah. um, yes, it's a very nice command to work with. Okay, so I'm going to delete this one. Um, I'm going to change the UCS to world. I'm going to take the plan view. And here I'm going to do a small change so that you know. So here everything worked fine, right? So nothing happened. The loft command gave me, yeah, the expected output. So look what I'm going to do. I'm going to do a small change to the curve and I will try to apply the loft command. So procedure is the same. I'm going to select these three cross section, enter, guide. I'm going to select this one. Okay, now AutoCAD does not give me the preview. Instead of it, it gives me an error, something called error code 114036. Um, it has found an error basically. But if I remove that guide, yeah, you will see the output. And if I select the other guide, yeah, it works fine. But if I try to select this guide, everything breaks down. So that happened, that issue came, that issue came because this guide does not go through this cross section. Or yeah, that's how you should interpret it. So if any of your guide curves does not go through this cross section, I mean, going through the cross section means uh, you need to have an intersection between this ellipse and this guide curve. And similarly, intersection between this circle and that guide. Um, okay, so if I did it something like this, so now, okay, let's go and, yeah, I'll show you this one and then I will discuss. So here, I moved the curve so that the guide is going through the cross section, but it is not intersecting with the path. So that is invalid as well. So what should happen is this guide has to go through this ellipse. So that has to be satisfied. If you are not satisfying that condition, then the law will not accept that particular curve as a guide curve. So this is something very tedious in AutoCAD. But if you go to other modeling softwares like SolidWorks um, and Siemens software, there are a lot of tools to uh, deal with this kind of this kind of constraint. Uh, so you can easily set the curve. You can force the curve to intersect with the ellipse. But here in AutoCAD, it is very difficult. So that's why AutoCAD is not the best tool to do 3D modeling. So I'm going to delete that one. Yeah, that curve is ruined. So yeah, um, yeah. So these are the completed results. So you can see the steps. So what I did was I yeah I created the bottom part, like following the procedure I previously described. Then I added what you call a cylindrical feature to the top of this one, okay, to the top of the bottom piece. So it's very easy to do that. So what you do is select the 3D solid. I'm going to isolate it so that I'm not seeing the other stuff. So what you should do is now take the UCS command, go for the paste option, and I will select this face as my XY plane. Then I take this uh, circle command and draw the circle. So let's say 7 mm radius. Then I can simply use the extrude command, select this circle and extrude it. Okay. So yeah, that's how you do it. I don't want that. I don't want this circle. End of object isolation. Okay. I'm using a command called plan. So that will give you the plan view. Simple as that. Okay. So yeah, that then you can do the top part. If you want, you can add the thread. And here I removed the thread actually because there was an error. Um, Finally, I did something like I combined the top part with the bottom part, then applied what's called a shell operation, where you are removing the material. So initially, we have something like this. So after shell, you have an empty container. So you can define a shell thickness like 1 mm, 2 mm, or whatever the accepted value, and remove the internal material. So since it is a container, you need to put some liquid in this. Okay. And remember, if you have like fillets, make sure that you apply the fillet before the shell operation. Otherwise, yeah. Otherwise, the results are not that correct. So it will not have the proper thickness in some places. So you apply the fillet, and the final operation would be the loft command. Sorry, shell command. Not a command, it is an operation. So you can find the shell under solid, and here we have the shell. Okay, so it is a nice tool. Loft command is a nice tool. So make sure that you practice this tool. So you observe the things that you find in real world. Uh, Say go to kitchen, look at your desk, um, table, and try to figure out what is say um, yeah, how can I model this? Something like that. Okay, so I have a mug on my table. So let me, yeah. So something like this. If you want to model something like this one, probably. So then how you do can do this. Okay, so something like this, you will not be able to get the entire shape with one command. Okay, so you need to do it in steps. So what you should do is should identify which section of the object can be modeled by which command. So that's what you do. You break this down into different sections. Or in other software, you call them as features. Like in SolidWorks, we call them different features. Um, yeah, if I have time, I will. Yeah, I will do some SolidWorks stuff as well. Okay, so yeah, you divide the shape into different sub component and model these components separately, and then finally assemble them. Okay, so that would be the best way to generate a model like this. So if we are doing something like that, I would uh, I would follow something like this. So I'm going to make a new file. So this time I'm just going to start with AutoCAD ISO. I told you that there is hardly any difference between AutoCAD ISO and AutoCAD ISO 3D template file. So yeah, so, yeah, therefore I can simply start with AutoCAD. What I did was I simply changed the visual style to shades of gray so that I can see the 3D object properly. So first I'm going to use, so this is what I'm going to do. So the container or the region where you hold the beverage, whatever tea, coffee, whatever you drink, water, um, I'm going to model that separately using the revolve command. And for the handle, I can use the uh, what sweep command. Okay, so that's what I'm going to use. Right. Let's see. The mug I have is about 100 millimeters tall, so I'll use that as a reference. Okay. Yeah, you can see it, but it is on my table. Um, Curving down. I will use arc for this one. I don't want to deal with splines for these kind of works. They can introduce something called self-intersecting geometries. Uh, Probably somewhere here. Okay, let me do that again. Okay, so this is what I'm going to do. I'm going to offset by 40. So let me get an idea. 45. 40. Let me Draw somewhere to there and move it by. Right? Go with arc. With that I have, and then I can go with the continue arc, which will be giving me a tangent arc to the previous section. And we'll drop it somewhere here. Okay, so this arc and that arc will be tangent. Uh, so what you have to do is you draw an arc, whatever the arc you need. Then you start the continue. Okay, look at this. So I draw this line. If I use continue arc, so this new arc will be tangent to the old line segment. So that is an added advantage. Otherwise, it is somewhat difficult to do these kind of um, what you call relationship addition in AutoCAD. Actually, I haven't showed you this one. In AutoCAD, um, is the parametric. Yeah, here. There is something called parametric relations. This has been there, I think, 2010 or 12. So quite a long time now. So what you can do is say, so line F8. Let me fix it. Can I fix it? Oh, yeah, locate. Okay. So let's say if I want to draw an arc tangent to this one, I can simply draw this arc and the coincident. Let me drop it here. Okay, right now the arc is not tangent to the line. So what you can do is make them tangent. So there is a tangent option. So it is telling me to select the first object and select the second object. Yes, now these are tangent. They should be tangent. They are not going to. Okay, yeah, now they are. Okay, now it's better. By the way, you can do that as well. There's a coincident relationship. Okay, let me undo. So what you can do is apply the coincident relationship between that point and that point. So it is automatically, yeah, happened. So now when I change the shape, let's say F8, so the tangent relationship will always hold. Okay, so yeah, yeah, you can do something like that in AutoCAD. But I was lazy to do those stuff. Um, yeah, that is why I that's why I used the conventional approach. Okay. Um, so if you want to follow this method, what you should do is lock this point and apply tangents between these two. And also, let me move. Let's see. And I will need to apply another relationship so that that point, and that point is coincident. Okay, so let me. By the way, you can set it to auto. I don't recommend it for normal stuff, but this kind of uh, for this kind of application, it's fine. So let's say something like this. I want coincident this point and that. Okay, uh, and let me push. Okay, let me lock this line. Right, and make this one horizontal. Okay, so that it won't run everywhere. That is the issue. So let me try to shape this profile. Okay, now that okay, I don't need this. Yeah, I think this is the cross section that I'm looking for. Um, so I don't need that line. Um, yeah, something like this. Then I will use the offset command and let's say the thickness is around. Let's suppose the thickness is around 3 millimeters. Then I can simply offset this and trim away the edges. And here probably apply a circle. Okay, let's say let's try to apply the fillet. No, it won't work. Let me apply a circle mid between 2 points and trim away this part. Come on, why is that AutoCAD dumb? Okay, let me take the circle command, inbox this one. Okay, something was wrong with my previous circle. Yeah, now it's working. Okay, so that is that. Let me apply fillet here. Radius 5. Okay, and I will apply a trim. So that is my cross section. So if you remember from the previous lecture, you need them as one continuous curve. So I'm going to use the join enter. So and make sure that the cross section is closed. So if that is the case, I can use the revolve command and get the shape. Yeah, basically that is the container region. Here, this part, this part. Now you need to work on the handle. For that, I'm going to hide this one. And yeah, let's try to draw the shape of the handle. Okay, so for that, I'm going to use the spline tool, SPL. say somewhere here. I will disable auto. Let me draw in the rough shape and then I can fine tune the curve. Control polygon. Say, I don't need the snapping tree. Let's see. Not that shape. Whether you could have brought the image into AutoCAD and then try to trace the border of the image. So it does not have something like this. Instead, delete this part. Okay, something like this. Yeah, it needs some work, but it is good enough for the demonstration. Okay, so you have the path. Now you need to define the cross section. I'm not sure exactly what is the cross section they have. Uh, yeah, they have in this shape. Um, but I'm going to assume it is more like cube-like shape, maybe more elliptical shape, so, so that it is much easy for me to draw. I and uh, I don't know. Ellipse was giving me some strange preview. Let's say something like this, perhaps. Yeah. So let me use the sweep command. So that is my cross section. This is the path. That is not good. So property. Let me try to rotate the profile. Okay, somewhat fine. So what I did was I simply rotated the profile. So previously you were getting something like this. It did not change. Yeah, you can see. You can see this cross section. So this was the original one, but now it is not returning. I don't know. This is what I may actually need. Um, so it is not exactly what I'm looking for. So I'm going to delete the path, and probably I'm going to do a small change here. Let's say, okay, remember this will not be the final output. You still need to do some um, modifications, especially at the very end. Okay, I don't want to put it that much. Okay, let's see. Wait, so I'm going to rotate the profile by 90. Yeah, kind of good enough. But remember, so here, yeah, let me bring back the mug, the main container. Yeah, here, you see. So here and here, you will need to do some work. But for this demonstration, I think this is good enough. Maybe you can apply a fillet, so that will smooth out everything, probably. Um, yeah. Okay. Yes, that would be the method you would follow to generate an object like that. So, right, in the beginning, you try out these simple shapes, and that is a good exercise for you. So you learn how to like decompose. Uh, I mean, how to break down these big objects into smaller parts where you can model them individually. So that is an important skill as a designer, sorry, and as a modeler. You should have that capability. Okay, so even though these items are very simple, they all have something to teach you. So yeah, so it's not they are not like very complex machine elements. They are not related to high-end engineering applications. It doesn't matter. Simply try them. So it will be, you will learn a lot from them. So that's how I learned when I was learning CAD, and I think that's a good way. Okay, so you will have to maybe fine tune this handle a little bit more, but I'm happy with this solution, with this output. Um, yeah, you can play around in your own. So all I used was spline, and here I created the cross section, okay, with the polyline. Make sure once you create the cross section, it is a polyline and it is a closed. Okay, so this should be yes. So by the way, there's a command called double OPS. So this command will be help you to bring back the last deleted object. Whatever you deleted, uh, whatever the last object or multiple objects that you have deleted, you can bring with bring with the double OPS command, or you call it oops. So they have, yeah, Autodesk people have nice sense of humor. Okay. Um, yeah. So remember, you can bring back old stuff with undo, but this is an alternative as well. So undo will undo the commands, but this will only uh, bring back the deleted stuff. So yeah, I use that command. WPS. Okay, I think I have run out of that one. Let's check it out. I'll have to undo that. Okay. So here, this c- cylindrical shape and the handle, so they are two different shapes. Okay. Sorry, two different objects. So this is one object and that is another object. If I go to property, you will see that there are two solids. But actually, this should be one, right? So unless you have broken your mug, uh, so this should be one object, right? So how can you do that in AutoCAD? How can you combine different solids into, say, one solid? So that would be our next topic. And this is called as Boolean operation. Okay. Boolean means like binary, but I don't know why it is binary, why they use this term Boolean. Maybe it is coming from very mm, like a very beginning. In the very beginning, they had only the capability to say combine two objects. Maybe maybe that's why. I don't know. I'm not. I haven't digged into that. Yeah. Anyway, that's how it is called Boolean operation. But remember, you can. Yeah, this can be. These operations can be say done between more than two objects, like three, four, whatever the number of objects. Okay, let's say if I want to combine these two, so there's a Boolean operation called union. So this will combine two or more solids, not only solids, uh, into one object, one 3D object. So since we are only dealing with solids in this section, yeah, I'll use the term solid, but it can be a surface or a mesh. I think you can combine meshes as well. I haven't tried meshes in AutoCAD. Um, by the way, if you love 3D modeling, I would recommend you to go and learn a software called Blender, not the blender that you have in your kitchen. So the Blender command, sorry, the Blender software. It is a free software, and by the way, you can even use 3ds Max or Maya. Maya. Okay, so these are for like pro pro 3D modeling, not related to engineering, but I don't know who that is. Like professional level, like 3D modeling stuff. Okay, so you can do sculpting, mesh modeling, uh, texture handling, you name it. Okay? And they are the same company. Autodesk is the company behind AutoCAD and 3ds Max, Maya, and lot more. Blender is a free and open source software, and it is becoming more and more popular. You will find a lot of like tutorials related to Blender, so it is picking up the momentum. Um, so if you need a software that will be free forever, then go with Blender. And if you just need to learn a software like then you have 3ds Max. And these are professional tools. They are used in the industry, not in engineering stuff, but in game development, entertainment related stuff. Okay, movies, commercials, and so forth. So yeah, it is free. Blender is free. It is about 277 megabytes download. And there's a portable version. Oh, that's nice. I did not think about that. Okay. Yeah, let's come back to our topic. So I'm giving you a lot of stuff. Okay, the problem, the question, I forgot the question now. The question is uh, how I combine these two. For that, we have the Boolean operation, and out of that, we have the union operation. So that will combine two or more solids into one. Okay, so what you take the union command, the command alias is UNI for union, enter. Now it is asking me to select the objects I want to combine. So I'm going to select these two and enter. Okay, now this is one object. Okay, so let me orbit. See, it is one object. So if I select it and go to properties, uh, yeah, you will see it as one solid. Yeah, simple, right? You have the union if you want to combine. And if you want to do the reverse, like if you want to remove material from, if you want to remove one from the other, another, then we have what's called the subtract operation. It's another Boolean operation. Um, okay, let me do this. Come on. Okay, let me take a copy of this one and show you something you can do. You see it? Uh, you see it? Okay. So I changed UCS to the back of this mug. So now this is what I'm going to do. I'm going to take the spline command. Spline. Ah, no, I'm going to take the circle command first. Draw circle here. And let me take the spline command. Oh no, I will take the line command first. Draw and take the spline command now. Finally. Uh, this is the north of 8. Okay, let me go to the plane mode, control vertices. Mhm. Let me apply trim here. Can I trim? Okay, I can't trim. I don't know. I'm not sure whether this will work. But if it works, that will be nice. To be a nice example. Okay, I don't need this line to hide it. Uh, and I'm going to connect these two splines using the join command. So let me double check properties that it is a closed object. Yes, it is. Okay, now this is what I'm going to do. So I'm going to select this one, extrude it, so ext, um, let's say zero point 0.5 millimeters, and I'm going to the properties and change the direction of the extrusion to minus zero point 0.5. So it is sinking into the base of the cup. And similarly, I'm going to extrude this one. So extrude, minus zero point 0.5. Yeah. Okay, now I select this solid array. Okay, let me take the array command. Enter. Type of array is whole array. So this is gonna be the center. Um, yeah, 6 is fine. Let's try it 7. Probably 8. Hmm, yeah, that's fine. I'm going to undo. Sorry, end object isolation. Okay, now I want to. So this is what I want. I want remove these petals from the mug so that it has like a nice imprint on the back, on the bottom of the mug. Okay, so I want to actually remove these petals and this cylinder from the main object. Okay, then how you do it? So you have union to add several elements into one element, and similarly we have subtract where you are removing material basically. So yeah, this is what I'm going to do. I'm going to subtract. So what is the base material? So this is my base object, enter, and object to subtract this, 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 okay, this, this. That is the difficult part. Okay, let me disable selection cycling. Enter. Okay, that's all. Okay. So now I have a nice imprint of that flower flower kind of shape on the bottom of the mug. Okay. So I could have used some like fillers, this kind of stuff. Uh, yeah, you get the idea, right? So that's what I wanted to show you. So if you want to remove materials, then we have the subtract operation. So yes, uh, the nice thing about 3D modeling is you can have a lot of fun with this software. So I won't say the sky is the limit. Actually, there is no limit when it comes to 3D modeling. Um, you can create anything. If you are like the god in this universe, like if you go to a tool like Blender or 3ds Max, then you have more freedom. I recommend you to go and check what are the projects these softwares had been used in. You can see this is like a photorealistic image. So this is a rendering. That means an artificial scene. You can see. uh, Maybe I will get fooled definitely if I saw this without any context. Okay, so that's the level of details you can produce with these tools, and it takes time. It takes time to learn such a tool, to master such a tool. Um, but it is a process that you can enjoy. That- Yeah, I can guarantee that you will enjoy it. If you like doing this kind of stuff, then you will definitely enjoy these kind of work. Okay. Uh, yeah, that is subtract. Okay, the third one is called the intersection. Um, this one is somewhat tricky. How can I show you this one? Okay, let's look at this example. Um, yeah, it is a toothbrush. So let me try to explain the intersect operation using a toothbrush. Okay, let me open this one on a new tab. By the way, I'm not promoting any brand. Don't get me wrong. Uh, right. Okay, where was I? Yeah, here. If you look at this toothbrush, let me. I need a better view. Okay, this view probably. Yeah, yeah, here. Let me open that file. So if you look at this shape, it has a very uniform shape, right? So the cross section is fairly uniform here. Let's forget about these color strips and only focus on the white part. Okay, and here it is slightly large, something like that. And if I look at the top view, okay, that means um, this view, this surface, um, it is kind of the profile is not that difficult. Let me try to get a different view of that. Um, yeah, that's fine. I'll do. Yeah. So actually, the toothbrush is the classic example I use uh, to show this intersect operation. So let me make a new file. Uh, blah, blah, blah. Okay, let me save this one first. Sure. Now, so when you if you try to model this chair, how can you do this? So the you should remember that you should notice actually. You should notice that the cross section is changing. And let's forget about the fiber part with the fibers and focus on the hand plastic part. And if you look at this one, also I will forget about these squiggly stuff. Uh, yeah, that will make our life much easier. Okay. Yeah. So yes. So if you look at the shape, you will notice that it is not uniform. The cross section is changing from here to the here. So it is not uniform. Um, if you may be wondering whether like so since you know about lock command, whether you should use lock to this model this one. Yes, you can use lock, but lock is too difficult because you need cross sections in every location and you need a proper guide curve. Not one, like multiple guide curves to say guide these cross sections along the uh, path you need. And that is a tough task in AutoCAD. So instead of that, I'm going to show you a different approach. Okay, so remember this method is valid for any object. Let's say if you look at from the um, like, how to put this. Okay, so this is what you should do. You should look at the geometry on two perpendicular axes. Okay, so you should look at it along two different axes. Say I will select this uh, axis and like look, yeah, this is not that clear. Okay, let me go to the other. Yeah, here. So one, I will be looking at this view. So yeah, so it is something like this. And the other view will be perpendicular to that one, and you will be looking at direction number two. Okay. So, so look at the object on like two perpendicular direction. You have to look at it from two perpendicular directions. And if you notice, if you notice that the cross section is same, or you have um, uh, like extrudable feature, extrudable shape on both of these views that you are looking, um, then the what you call intersect command might be a solution for your problem. Okay, so look at like mutually look at the object from two mutually perpendicular directions, and on the view that you get from this direction Um, if you can generate these views using the extrusion operation, then yeah, the object may be generated using the intersect operation. Maybe that is somewhat confusing. Let me show you. Then you will understand it better, I think. I think. Okay. Let me bring a copy of this one to AutoCAD. Take a look. It's like 250. Uh, there are no toothbrushes that long. Maybe it is 12 centimeters. Yeah, let's go with 13. Yeah, I'll use 13 millimeters. Yeah, I could have measured one. I'm too lazy to do that. The scale base point is this point. I'm going to use the reference option. This is my reference length. So that's going to be 130. Okay, that's fine. I don't need that line. I want to make it more transparent so that I can trace the shape much better. Should I use splines? Yeah, let me use splines. Splines. I don't know, you can use lines and arcs for this one as well. Okay, let me use the polyline so you know what another way to do it. Um, so I can switch between, the nice thing about polylining, you can switch between lines and arcs will be tangent. So arc, okay, let me undo polyline. You need to follow the shape as much as possible. Yeah, I think this is not actual project. I'm not that worried about following the shape precisely. So now I can let me extend it further. Then I can offset it by say this amount. Top part. So this is not tangent. So yeah, I'm not that bothered about the tangency. Um, okay, that's fine. I don't want to spend too much time on perfecting it. Right. Then I'm going to close this edge as well, and I will select everything. Will select everything. Apply join. So that will give me 30. I will double check. Yeah, it is a closed polyline. Yeah, that's fine. Okay, so you now you have to draw the other view, which is perpendicular to this view. So I mean, if you look at this brush from this way, so what is the view? So let me draw it somewhere here. So this time I'm going to do an assumption, some assumptions of the shape. So this will be the symmetric axis. Actually, you need better images actually when you want to trace an object like this. Yeah, I don't have the images, so I'm going to assume it. So I will apply some filters to trim, sorry, um, get the smooth shape. Let me take the arc command. I want to make this part little fat so that you have a better grip. Okay, I go it down and let me draw that here. Yeah, I'm going to. Okay, so this is what I'm going to do. I'm going to, for the parametric stuff, lock it. We'll lock it here. Then I'm going to apply tangency between these two. Then I will manipulate this carelessly. Yeah, since I'm using tangent relationship, AutoCAD will maintain the tangency whatever I do. Okay, then I can trim away this part, that part, and that part. Yeah, that's fine. Mm, Let me do a few more changes. Right. Okay, I think that's fine enough. Okay, now I will select the curves, lines, and join them together to form one continuous polyline. Yes. Then I will apply a mirror. It's not gonna look nice. Yeah, but you will get the idea. That's what is important right now. Okay, so let me take a copy of not that one. Right. So I think that is good enough. So this is what I'm going to do. I'm going to take the extrude command, ext, and extrude it. Right. It's not extruding. The problem is I'm not right. Okay, so I don't worry about the length, so I will simply extrude it something like that. Okay, let me. This looks ridiculous actually. Mm, do some changes. So that's why you should always bring an image file as reference. Uh, these kind of rough sketches are not good. So I'm going to extrude that one as well. Yeah, something like this. So now I'm going to rotate one of them so that it will have an intersection. Then I will move it. Now it has an intersection. Okay, now let's see what the Boolean Juni intersection has to offer. So what you select is these intersecting geometry, enter. That's all. So what you are extracting is the intersecting volume between those two solids. It is not that bad. I thought it would be stupidly ugly. Uh, Not bad. Okay. So you need to add the fibers and probably have some fillet to smooth out the edges, sharp edges. You can do like edge fillet, uh, like this edge, that edge, and something like this, enter, and fillet edge, edge, this edge, enter. Yeah, you get what I mean, right? So you can smooth out these rough, sharp corners by using the 3D fillet command. And make sure that you apply them in pairs, like here, because it's a symmetric geometry. Um, what you could have, what I could have done is model only half of this one, and then apply the fillet, whatever I need, and then mirror the other half and combine it later. So there are different ways. Um, like that. So Yeah, that's a nice example for intersection. So what I did was I created the uh, cross section by looking at the top view and the side view. Then I extruded these multiple views and intersected them using the rotation command, what you call rotation gizmo. Okay, so then I used once you have an intersection, proper intersection between these uh, solids, then I used the intersection operate Boolean operation and extracted the intersecting volume, so which will give me the solid I need. Okay, so let me save this one. Yeah, so it's a nice little trick that you should use. Uh, yeah, but remember you need to observe the solid. So if whether it has that property I mentioned. So look at the object and check whether like you have extrudable cross section on two perpendicular views. If that is the case, yeah, this can be a candidate for the union operation. So it is a nice tool, basically. That's what I want to highlight. Right. So those are like the main tools that I wanted to discuss. Um, let's take an example, like this one. So this was one of your assignments. Uh, yeah. Let, let's see how can you model this preview in preview. So what I'm going to do is, let's say, I don't want that, I don't want that, I don't want that either. I will make a new file, AutoCAD ISO. You can use the 3D file, that's fine. Yeah, but I'm going to use the 2D one there. Outer, that's all I'm going to use. So let me increase the thickness and the color as well. Okay, let's see. So I have a rectangular shape, the base. I will start with the base. It doesn't have to be the base actually. You can start anywhere. Uh, if it is comfortable, that's fine. Comfortable for you, I mean. Okay, so let me start with the base. So, and I will introduce you another command that I will be using very, very often. And I will not use extrude command for this one. I will use the command that I'm going to discuss. Um, yeah, very shortly. Uh, yes, so this is 150 and 90. So let me draw a rectangle, rectangle. Okay. Okay, now what I'm going to do is I will extrude this one by how much? 25, 50, 25. So you have this shape. I don't like the grid. I'm going to turn off the grid. So I have this check. Um, so next I'm going to um, yeah, no, I will not cut away this one first. Then I will draw this part. Okay, for that one, for this purpose, I need to change the UCS. So I'm going to take the UCS command, um, enable snap. Let me go for the midpoint. So I'm going to define this. So this is my new coordinate system. So I'm going to the top view and I will draw the shape. That would be 25 units from this edge. Uh, okay, draw line, offset by 25. Um, again offset by 80. Uh, offset by 280. Offset by 280. Um, sorry, 250. Offset by 250. Offset by, okay, I will wait. Uh, I will draw this line from here to there. Then I'm going to offset by 80. So this is 60. I'm going to do another offset by 60. So right now you will see just a random bunch of random lines. Yeah, I will solve that very shortly. So now I'm going to go to the top view, get the fillet command, set the radius to 0. Yeah, it is there. I'm going to use multiple options. That is that. Then I go to here. So that is this. And I will apply a fillet here. Okay, so I have the rough sketch. So then again, I'm going to offset by how much? 80. And then again, I will apply a fillet here. So that is 45. Then I'm going to apply a offset 45. I'll apply a fillet, this time with a radius of 30. Again, I will apply a fillet radius of 70. Then I'm going to trim away that part. Uh, can I trim? You should be able to. Why? 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 Eh, okay. Yeah, you have the basic profile, right? So I have this basic profile. Okay, now I need to extrude this by how much? 30. This by 60. So this is what I'm going to do. If you look at this, it is not it is not in uh, it is not suitable for extrude right now. But still, you can do the extrusion. But not with the extrude command. There is a command called press pull. This guy, which is a very useful tool in AutoCAD. Um, you can actually replace 95 at least of your extrusion with the press pull. So this is a very nice tool in AutoCAD. Again, I'm telling you. So I take the press pull. What I do is I click inside this region. See, AutoCAD is highlighting. When I move the cursor, it is highlighting the region for me. So I am clicking inside this closed region. Okay, remember it should be a closed region. If there is a small uh, gap in somewhere, this might fail. Okay, now see, it is extruding. So the distance is how much? 30. So I'm going to extrude by 15 this way and extrude this way by 15. Simple as that. Neat, right? This one is 60 millimeter. So I'm going to extrude this by 30 this way and extrude that by 30 that way. Beautiful. See, enter. So then you need to cut away this part. Let's do that. This is 40 and that is 30. Okay, I'm going to use the UCS command again. Space. This is going to be my XY plane. So I set the plane. Circle. I'm going to draw the circle here. The diameter is 30. Diameter is 30. Okay, it is 40, 30. Okay, this is what I'm going to do. So I'm going to move this center, center of circle. Base point is that one. The destination is at mm, minus 40, comma minus 30. Okay, that is nice. Then I'm going to draw a line from the center going all the way, and I'm going to offset it by how much? 3 millimeters both ways. And I don't need the line anymore. I'm going to delete the center line. Trim. Okay. This is the issue with AutoCAD. It sometimes does not recognize when you are working in UCS. Regenerate. Let me hide this one. Select hide object and trim. Okay, now it is working. Uh, okay. Let me draw a line here. Right click, isolate, end object isolation. Now I need to remove this part. So you could have extruded this one, then apply the union operation, sorry, subtract operation. But if you have press pull have you covered. You simply press pull that. Simple, right? Okay, I'm going to undo that and show you again. So similar to the extrusion, you can use press pull to remove material. That means cut material from your existing solid. So you have a closed geometry, closed object like this, then use the press pull AutoCAD will detect the boundary, select, click inside this region, and drag it. So if you are going into an existing material, existing object, AutoCAD will simply remove material like this. Okay, I will undo it again. If I go the other way, this way, you are going to add material. Now this is an extrusion. So previously it was a cut, but this time I don't want an extrusion. I need a cut. So I'm going to go the other direction. And here we have the solid with the cut. Okay, simple, right? So, okay, now I want the top circle here, top circle cut. Again, I'm going to use the UCF command, paste, change the coordinate system to the top face, and draw the circle here. The radius is how much? 15. The diameter is 15, 15. And I will move it by okay, 13, right? Yeah. Then again, I'm going to use press pull. And before that, I will hide this one. Okay, press pull and blah. So you have the cut, the hole. So that's why I really love the press pull command. Okay. Okay, I'm going to do the same thing again. UCS space top. So this is 5 millimeters and this is 126. Okay, let's do some math. So that gap would be 150 minus 126 divided by 2. So let me draw a line. Okay, no, I can use, do I have the copy edge command? Okay, I will simply draw a line. I will teach you that command later. So I'm going to draw a line with 5 millimeter height. And then I'm going to use offset. For the distance, I will use cal as because I want to access the calculator. The distance is 150 minus 126 divided by 2. So that is the offset distance. Enter. Select the line. Come on. Oh, okay, I need to hide this one. Okay, offset. Yeah, 12 is the distance. Right there. Line 126. That's all I need. So I'm going to bring back the solid. So now I want to cut away that part. So simply press pull. Okay, it is not detecting. Okay, yeah, it has identified. Ah, I made a mistake. I think I made a mistake. No. Ah, I made a mistake. Huge mistake. Not 12. That is actually 30. So this is 90. But now I can do the press pull. Okay, sometimes this can happen. So it did not detect that it has to remove material. So in this case, fine, we have the subtract command using click. Select it and remove that. So sometimes pressful can fail. Yeah, you have an example right now. Okay, so this is the basic shape. One thing that you have to do is add these four holes. So let me take the UCS again, paste it here, circle. The diameter is how much? 12, 12, 12, 12. And let me move it 12 here, another 12. So I will apply mirror for the circle. Again, another mirror. Now it's all about press pull. By the way, you could have uh, created one solid cylinder and mirror that cylinder two times, and then you apply union operation. Okay, but I am too lazy. Yeah, press pull is nice, so I use that. I use that a lot. So that is your shape. Then that is 12 millimeter radius fillet edge, radius 12, right? And then I will use union operation, combine everything to one. So that is one solid. And then I can simply apply some fillets here. Fillet radius is 4 millimeters. Where do I have fillet here, fillet there. Okay, fillet edge. The radius is how much? 4 millimeters. Here, one, here, another one, here, one. Yes, it is done. That's all. Okay, the beauty of having a 3D solid is you can go to a layout. Let me delete the existing one. Existing viewport. And here I can bring the solid as a drawing from model space. So you can set the scale and what to display, accept. This is the end elevation. That is the plan, like that. Simple, simple, right? Um, Let me update it. Update the view. So I want to do scale. 4 is too small. So you can compare. Yeah, and the nice thing is when I move one view, when I move the parent view, the child view actually move together. So that is a nice feature. Yeah. So by the way, you need to have include the dimensions. You need to include the title block. You need to include the label, text view labels. So there are stuff you need to add manually. Even the center lines, center marks, you need to add them manually. But still, look at you are not missing anything. If you have modeled it properly, um, yeah, it should be here. Yeah, that is the beauty of 3D modeling. Um, yeah, so this would be it for today. It will be a long lecture. Um, and I want you to do the previous 2D drawing examples and create 3D model. So that will be a nice exercise for you. Not one exercise, a lot of exercise. Right. Okay. Then I will stop this lecture here. And yeah, have a nice day, everyone.